Hey guys, I think you're doing good. In this video, we will talk about the Java implementation of binary search. The binary search algorithm in the dry run, I have discussed that in the previous video. If you haven't watched that, please watch that because unless and until you understand the algorithm, the flow of the program, you won't understand the implementation. And if you're already aware of that, then you can progress with the explanation. Now in this program, I have used the main method where I have used the buffer reader class to take the console input. Here is our array. Array is a homogeneous collection of data. So here integer elements would be stored in this array and the number of elements is 10. Now, next I have used the a loop to take the inputs from the console. Means the user would be entering those numbers. Now, since it's an integer array and the primary condition for binary search is that the array, whatever array you are taking, before using the algorithm binary search, you have to ensure that the array is already sorted. Okay, so the prerequisite is the array needs to be sorted either in ascending order or descending order for the case of integer array, or you have to sort that in alphabetical order or in reverse alphabetical order in case of characters or strings. Okay, so let's assume that we would enter the array, whatever array elements we are are putting as input here, we would input that in such a way that they are already sorted in ascending order. Now, with that assumption, let's see how it works. So, the index loop is generated. The index loop starts from 0 to array.length minus 1, and the index loop variable is incrementing by plus 1. Now, inside that loop, I am printing a message to the user that it to enter a number. And after seeing that, I would enter that number. Whatever number I am entering, that would be read as a string by the method readLine. ReadLine is a method inside the buffer reader class which helps us to take the console input to read a line from the console window and convert that as a string and it returns as a string. That string we are converting into an integer with the help of parse int method from the wrapper class integer, and that we are assigning in array at ith index. Now, when the whole loop executes, then the whole array would be filled with elements, integer elements. And once we are done with that, we would take input, we take another input, the item that we need to search. So here is the message that would be appear in the console window, and the user would again enter a number that we would store inside item. Now, in binary search, whatever we discussed in the last video was we had three main parameters, very important parameters in binary search, right? Low, up, and mid. Low is the lower bound of the array index, that is 0 for our case now, and 0 for naturally all the cases, usual cases. Now up is the upper limit of the array index. So here is array length minus 1, and mid is a variable that we would be using in the next couple of lines of code, but here we are not initializing anything in that. Now next we are using a flag variable just to indicate whether we have found or not, like we had used in linear search program. And similarly here also we have to use a boolean flag variable. In linear search video I used an integer flag, and I tried to show you that we can do that same thing with the help of boolean variable, boolean flag also. So here I have used the flag variable as false. If you haven't watched the explanation of linear search and you are struggling to revise your preparation for data structures, you can also watch my linear search video to get a better clarity. Now in this logic part, whatever I have done, I would execute this loop till low is smaller than up. If this is true, then only we would execute this block. This is the body of the while loop. Now the first task what we are doing, we are finding the midpoint of the array here, and we are checking whether the item whatever we have taken as input, we have been given as input, that item is greater than array of mid or smaller than array of mid or equals to array of mid. Here I have used if and else structure. So this means that any one of them would get executed, right? So if item is greater than array at mid position, means the element in the mid position is smaller than the item. That means the item has a higher probability of being lying in the right sub array, right? Mid is the mid position if the array is sorted in ascending order. if the item is greater than the mid position's value, that means the array, the item that we have taken as input for searching, so that would lie in the right side sub array of the mid. Okay, so for that we have to update the lower value, lower bound to mid plus 1, because mid plus 1 will be the starting position of the sub array that we are interested to look at, and the upper bound would be as usual the length minus 1 only. Okay, so this is the concept. If our item is greater than the mid value, we would shift the lower bound to mid plus 1, and if the item is smaller than the mid value, then we would shift the upper bound to mid minus 1. Because in this case, suppose imagine a value, a item that you have taken as input, and that is smaller than the mid value, that means it would lie in the left sub array only. The left sub array starts from 0 to the mid minus 1 index, just before the mid. Okay, before the mid position, that array, that sub array is the place where you are interested to search next. So that's why we are moving the up position to mid minus 1. And now suppose our mid position value has matched with the item. If doesn't work, else if doesn't work, that means else will work. If it is not greater than, it is not smaller than, then the only possibility is that it is equal. And if it is equal, then what we are doing, we are storing the flag variable as true. So if the flag variable is true, that means that we have found the element, right? If the flag variable is true, that means we have found the element. And then we are also printing the position where the item has been found. And usually what we do, if it has been found, then we don't need, we would not search again, right? So that's why we are using the break statement to jump out of the loop. So the break statement, what it does, it jumps out the control jumps out of the loop, right? So if we have found, then we don't need to iterate again, so we are stopping the loop here. And when this loop, this while loop executes, then we are automatically shifting our focus from the whole array to sub arrays, and then we are again breaking that into sub arrays. That means what we are doing, we are not comparing all the elements of the array with the item that we had done in linear search. So in binary search, we are taking only the parts of the array and we are searching inside that. So here the time complexity is very much improved as compared to the linear search. Here the time complexity is O of log n. Time complexity is another topic that I would discuss in the later video, but for the timing, you understand that time complexity analysis helps us to understand how a code performs, how a program performs when the input increases and the size of the input increases. So here the time complexity of binary search is O of log n, that is much better than the time complexity of linear search, which is O of n. That means as you increase the size of the array, the time complexity increases for linear search. O directly proportional, the time complexity is proportional to n. N is the dominant term. Where in binary search, the term is log n. That's much better. So outside the loop, when you're coming outside the loop, it has, if it has been found, then the flag would be set as true. So this will not execute, because if it's true, that means we have found that, so this part will not execute. But if the element is not present in the array, then the value of the flag variable would be false only, because by default we have stored false in it. So that's why when it's false, when it would remain false, that means it, we have not found, we have not, the array, the element is not present in the array, right? So that's why we are printing this message as not found. Okay, this was the whole logic, and why we have implemented part by part, I have explained. Now let's see how it works. Okay, let me run the program for you and give some inputs and try to see whether it's working fine or not. So here again we have to enter the 10 numbers. So let me enter the 10 numbers. Now the item to be searched. Okay, one mistake I did. So I had to input the number in ascending order, because it's the prerequisite that we have to input the number as sorted. And another thing we would have done, that we have to then again implement bias bubble sort or any other sorting algorithm, or selection sort, any other kind of any algorithm for sort, and we can sort that, and after that we can implement the binary search. That we could have done, but no worries, you can all just test the logic is working fine or not. So let me do that. Now I am entering the numbers as they are in ascending order format. Now see, I have input the numbers and they are all in ascending order, 12, 13, 45, and they're gradually increasing, right? So now I want to search a number. Suppose I want to search 131 is present or not. So found at position 10. So at the 10th position we have found that. Now suppose I take a number that is in the beginning, whether that works fine or not. Let's check that. Now the item to be searched. Now let's see, 12. Found at position 1. Yeah, it's working. So in the left sub array, it has found one case, this one. In the right sub array, that was the previous one. Now let's give some number that is not present in the array. What happens? Let's see. So this number doesn't belong to the array. So we are getting the output as not found. So here we are with the output. It's working fine. And this is the code. You can take a snapshot for your reference, or you can also refer to the blog links that I have shared in the description, where I have explained the algorithm and also shared the code implementation. There also you can get the code. So that's it for today. Meet you in the next video, and prepare well for your exams and all the best. Let's meet in the next video.